My name is Connor. I am a technical product manager at Brand Expedia here in London, and I'm going to be doing a little intro for tonight's kickoff. So first of all, welcome. Thank you very much for coming. We're super excited to be sharing this event with you. One of the reasons we do these tech events is so we can share like a small subset of some of the problems we face in Expedia and some of the solutions we have. And not so much because we think we have all the answers to all the problems. We definitely do not. But just by sharing with you guys, we feel like we can learn a little bit, and hopefully you guys can learn a little bit too. So, you know, maybe at the end we can march off hand in hand, a little smarter and a little happier. One of the stated mission statements at Expedia is to revolutionize travel through the power of technology. And one of the things we've noticed here is that you don't revolutionize anything by just staying the same and never changing. Okay? One of the big factors for the turnaround of this company over the last 10 years has been like a focus on like engendering a culture and environment where we're not afraid to do new things or try new approaches, and challenging the status quo is like celebrated and not feared, right? So you'll see that like in the evolving tech stack over the years, our commitment to agile. But for me, I think the biggest observation, or the biggest observation of this, I guess, is when you look at our culture of commitment to test and learn as a philosophy, not just in engineering and product, but everywhere. Which is a pro segue because tonight's presentation is by Ralph Jones. It is how Expedia A/B tests, basically. Ralph is from Birmingham, I believe. He loves Barry Manilow and cabbages.
I'm going to use the mic. Can someone just wave if it works?
What?
Nah? Thanks, man. Yeah, thanks, Connor. Good intro. So yeah, I'm Ralph. I lead the experiment engineering team here at Expedia. We're kind of a slightly small team in the grand schemes of how big Expedia is. So Expedia, and what I'm talking about here is Brand Expedia. So that's any of the websites you see that are expedia.com, .co.uk, all of those. There's also some others, so we've grown quite rapidly, so we've acquired some other companies, and so our whole presence has expanded. And what I mean by we're quite a small team is that we are an engineering team who provide A/B testing tools to the wider organization. We have engineers who are in the US, we have engineers in Europe and in India. And Expedia, Brand Expedia, is worldwide, so that expands that even more. We're talking about going to Australia, China. So we're talking about supporting a really big community of people. And we're not even talking about just engineers. So we're not talking about coders who are going away and implementing A/B tests. We're talking about members of our product community who are designing the tests that are going to run across our sites. So it's a really, really big community that we are supporting. And one of the things I'm going to highlight from what Connor was talking about is actually in Brand Expedia, what we have is a very strong test and learn ethos. So it comes from the top down. And we do it for everything. And the whole idea is that what we want to do is we want to fail fast. So we want to try things out, but we also want to evidence, have we actually done what we expected? And what I'm going to be talking about is the engineering side of all of our A/B testing. So how do we actually run A/B tests on a kind of technical level? I'm going to say bits of this are going to be somewhat technical. I don't know how technical. I don't actually know enough about all of you to know exactly, but I'll leave time at the end for questions. So if any of the bits don't make sense, please ask me at the end and I'll go over it again. Or just talk to me at the end and we can have a chat about it. That would be great as well. And then actually, it'd be really interesting to just get a show of hands of how many people in the room actively use an A/B testing tool set in their day-to-day job. Okay. So we're talking, I think that was about a third of the people here are actively using it. So that's quite good. So I'm going to guess that the remainder of people, some of this stuff might be fairly new to them then, which is good. So I'll run through what are the basics of A/B testing. I'm going to talk about what we have in Expedia. So we have internal tools, and that's what my team maintain. So we engineer and maintain those solutions. We also use third-party tools in Expedia. So I'm going to focus on our internal ones. They're the ones I know. So that's what I'm going to talk about. And then I'm going to give a bit of a timeline of how we got to where we are now. And in that, some of the lessons we learned whilst we were engineering these solutions. So, yeah, starting from the very top. What is an experiment? The idea is that you have a hypothesis, you've got some idea of a way to improve the site. So in this particular case, something very visual. So we want to run an experiment. At the moment, let's say it's on the flight shopping path of the Expedia.com site. We have a red book button. And our hypothesis is if we change the color to something a little bit more friendly, like a blue color, that we're going to get more customers are going to want to engage with that button and spend their money. So what we're looking for is to run a test where we send 50% of customers see the blue button, 50% of customers see the original, the control experience, the red button. And then what we're looking for is to see whether more people went on and booked something when they clicked on the blue button. That's what we're expecting to happen, and that's our hypothesis. That is a simple experiment. In Expedia, we don't have many of these left that are this simple. We picked all of these up a long time ago. Most of our tests now are running all over the stack. So it could be some change to a search algorithm. Maybe you want to start promoting certain types of hotels and see if that results in people booking hotels. That's the kind of thing we might be thinking about. And they're happening at all levels within our technology stack. And the other thing to highlight is that we run hundreds of them. So at any given time, we're not talking tens of active tests, we're talking hundreds. So that's an interesting fact within Expedia. We are very test and learn. So the next bit from that logically is like, well, how do we actually work out which one was the winner, right? It's no good running a test without being able to prove which one was the success or not. Actually, you can't see that too well. But the idea is, there it says control, the red button, there it says test, the blue button. And the idea is that we'll send 50% of customers, so 10 million of them in this case, to see the red button, 10 million of them to see the blue button. And then what we're looking for is our success criteria. So in this particular case, we're looking at did people go on and book a flight? That's our success criteria. And what we see in this particular case is that 1 million customers went on and booked and they saw the red button. So in that particular case, we had a conversion of 10%, right? 10% of customers went on and booked. For the test experience, we have 2 million people went on and booked. So therefore, we have a conversion of 20%. And what you're saying then is that the uplift in conversion was 100%. That's a pretty good test, I think. Agree. We'd probably make a lot of people happy with that one. The main problem we have, the problem space we have in engineering a solution to this analytics problem, is the time difference between the exposure to the test. So when did they see the button, and when did they actually go on and book? For certain of our lines of business, people can take a long time before they actually reach a decision and go ahead and book something. So we offer cruises. Those are quite expensive, and therefore people are a little bit more hesitant about making their choices. And so it could be weeks between they were exposed to the test, i.e. they saw the red button, and they went ahead and booked. And we need to track that and make that join to be able to deliver this analytics. So within Expedia, we have like a typical experiment life cycle. And God, the color is terrible on this thing. You cannot see it at all. But we have some internal tools, and that's what I'm really going to be focusing on. So we have, here is a screenshot of our admin interface. And what would happen typically in a life cycle of a test is somebody would become the experiment owner. That might be someone more product focused, project manager, that kind of role. They would go to our admin facility and self-serve. So, you know, even though I'm the leader of the experimentation team, I don't know what half of the tests are that are running across Expedia. I don't get involved. We provide the tools and they're entirely self-service. So the team will go away, they'll create an experiment, they'll have an option to say what their treatments are. So in this case, the test treatment is a blue button. And what they'll do is they'll start off at 0% of people seeing the blue button. What this allows the engineers then to do, so then the person who created the experiment would pass on the ID or the name of the experiment to the engineers. The engineers will go off and they'll code and say, if we're told to show the customer the blue button, then we'll output some CSS here, which will be the blue button. And that allows them to code in the dark, which is another pretty useful thing. So one of the things we're pretty good at in Expedia is the concept of continuous delivery. This is one technique to allow that. So let's say it wasn't as simple as this, and it was a big feature that was going to take, say, a month before the engineering work was complete. That work could be continually going out to production because it's switched off. Right? So 0% of customers are being exposed to whatever code is happening here, so it's safe to go out to production. That's the theory, right? So that's pretty cool. So then when you've finished your engineering work on that particular experiment, what we do is we then turn it on. So here we're setting the test to 50% of customers will see the blue button. All that's going to happen then is when they ask our code base, which experience should we see, there's an algorithm that runs and it will work out, okay, well, I'll put you in this bucket, I'll put you in that bucket. And then after running the test for a while, and I'll show you, we have a dashboard that shows you the results of the test pretty quickly. I'll show you that in a second, but you then work out which particular treatment was the winner. So in our case, we had this incredible 100% uplift with the blue button, so it's pretty no-brainer, we'll go with that. So what you do is you basically change this percentage from being 50% of customers see the blue button to 100% of customers see the blue button, and everyone's happy. So that's it on, and then in theory, this bit's a little bit of a difficult one to sell because then you've got a bit of technical debt that the engineers have to go away and get rid of at some point in the future. When they get rid of that, the blue button effectively is the control experience of the site, and you've completely moved away from the red one. So that's a typical life cycle of experiment. So we have this dashboard which allows you very quickly to see the results of experiments. So it's near real time, and this is our test and learn dashboard. What you'll actually see is effectively it's showing you what I showed you earlier. So here we're seeing a conversion figure to say that the blue button is converting positively at 100%. So great, that's most likely to be our winner. But there's also some other bits and pieces. So in here we've got a concept of a sample size. Right now we can't be certain that it's 100% positive because we've actually hardly exposed it to anyone right now. That's the idea of the sample size, basically. At what point do you reach statistical significance? And then you have the idea of probability, so how certain are we with the result of it? And that is a combination of a few bits and pieces. Basically, we have some figures that we tweak continually, but the main point from that is that we're never 100% certain. So our probability calculations, we don't run at 100% certainty that the test is a winner. So there's a percentage of them will actually fail. But we actually kind of, not fail, sorry, they'll give you a false signal. So a percentage of them might come out negative, but they were actually positive, and vice versa. But the general idea is that as long as there's only a few of those, you'll keep going up. You might just do that occasionally. And if you, most of the time what we see actually is if it does go negative, people are like, that test idea was amazing. How could it possibly go wrong? And they restart it and try again. So there's a couple of other things that are quite cool on here. Is that this is kind of a very Expedia specific dashboard. So you'll see that we list out a lot of the information. So how are you affecting each of the different lines of business with your test? We can go into quite a lot of detail. So we can pick out how did mobile customers do, all that kind of thing. And we have this quite cool cross-check ability. So have the engineers actually coded the test correctly is the idea of that. If my flight test, which is what we've got here, suddenly starts running on hotel pages, then we've got a problem, and that 100% will start going backwards. So that's and that's our dashboard, and the main thing that we have, the quick view, let's say, of how your experiment is doing. So I said that we have our internal tools, and I've kind of just shown you a couple of them. So we have internally for running experiments, we have our own in-house code base. We call it abacus, or we like to call it the abacus. And then we also have this test and learn dashboard, which I just showed you. I'm going to talk a bit more about how our in-house tool actually works. I certainly find it interesting. God knows if anyone else does. And then we have externally, we do use other third-party tools for running experiments as well. So we have a web analytics platform. So the test and learn dashboard that we have is great for seeing real-time results of experiments, seeing it quickly, giving everybody a very easy to look at a glance, how is your test doing. We also push the same experiment data out to our web analytics platform. So if you wanted to run a particular query, run a report, which our test and learn dashboard doesn't offer for you, you can go and use the web analytics platform. But that generally means then you've upped your skill set a little bit. Perhaps you need to ask someone with the ability to run these reports to help you out. And then bolted onto that, we've got a client-side tool called Target, which is kind of like a bolt-on to that web analytics platform. A bit like Google has Google Analytics, and they have their A/B testing thing, which is kind of on top of that. And I'm not going to talk about those at all. I'm just going to talk about our in-house ones. So how the teams actually use Abacus. So we had the example where you need to choose which experience is the customer going to see. And we're going to send 50% to the blue button, 50% to the red button. How does that actually work? We have our web application. So this is the thing that's going to render the button. The engineering teams of this web application will use our SDK. So we have an Abacus SDK. And ask it the question, for this customer, which treatment should they receive? And then they can basically use an if statement or other things to decide which treatment to show. To do that, this needs to know a little bit about the experiment. So we have some metadata about the experiment. That's pretty much what's the distribution. So that's kind of what we're interested in. We need to know it's 50-50 to know where to put people. And then once we've got that, probably like the most important part really is we then send which treatment did this customer see to analytical systems. So we have some kind of data capture solutions which allow us to push data to the different analytical systems, and we have the data going out to third parties. As I showed you, we have other analytical systems, and then we have our own internal data set, which is what powers the test and learn dashboard. One thing that's worth pointing out now as well is a couple of concepts that are very important to experimentation. So One is that we need to randomly allocate customers to the different treatments. It has to be random if we introduce any kind of bias to that. So if we start saying, well, we'll put mobile users in the control and desktop users in the test, we're not going to get the results we're after. We can't do that, that's not allowed. So this has to be random, the allocation, and it has to be consistent. So if a customer sees the blue button on day one and they come back a year later and the test is still running and it's the same customer, they have to still see the blue button. If they see a different treatment, then we don't know which one to attribute the success to. Right? So there are a couple of very key pieces. So then the actual SDK part of it, how does it actually work? What happens is, first of all, we ask the question, has someone forced themselves into a given treatment? This is something that's an internal tooling. So an Expedian, someone working for Expedia, can push themselves into the test treatment. When I was saying about coding in the dark, if you didn't have this ability, you'd never be able to know whether it was actually working in production, right? So first of all, we check, have they forced themselves into that treatment? And then this is the bit where, who knows if I can explain this? try this out. Made harder by the fact I don't think you can probably read that. But anyway, how do we actually allocate someone to one of those buckets? For me, it's surprisingly simple the way it works. And that's probably one of the things that's good about our internal tooling. So for every customer, we have a unique ID for that customer. That's pretty standard, right? So whether it's, everyone has that, whether it's a kind of session ID or some long-living cookie which you put a unique ID into it, we effectively have the same thing within Expedia. So we allocate every customer an ID. We take their customer ID with the test ID. I'll come back to why we join them together. And what we do is we join them, concatenate them effectively. And those two values become the seed for a random algorithm. If you think about a random algorithm, usually you would want it to be completely random. And so you'd seed it with something like the current time, because that constantly changes. And the reason you're doing that is the seed influences particularly the first number that will come out of your random algorithm. So if you put the same seed in over and over again, you're going to get the same first random number back from your random number generator. I hope that's kind of clear. So the idea there is that, let's say this customer came along and their seed was 1, 1. Then their random number allocated to them would be 0.2. Well, if we've got a 50-50 test and it's less than 0.5, right, we'll put them in a control group. And the good thing about that is, as long as their customer ID doesn't change, as long as their test ID doesn't change, they'll always go back into the control treatment. Like I say, right at the end, I'll leave time for questions, so if I'm not making any sense with this, we'll come back to it. But maybe like if I run through a couple of others, so a customer with ID of 2, same test, they get a different seed, they get a different random number, therefore they go into the test treatment. And the reason we include the test ID is that you don't want to go into the same treatment for every single test across the whole site. So we want you to be randomly reallocated to every single different test. When you've got hundreds of tests running, kind of crucial. Yeah. So like I say, that's kind of the end of how does our stuff work. I'm now going to go through a kind of bit of a timeline of what have we been up to, how have we got to where we are, and I'll cover how we actually technically run our internal test and learn dashboard, what's the analytical pipeline there, what we're working with. So from day 0 with Expedia, which I think was like 90s, I actually don't know. I've been here for 3 years, so it was way before that. there was some giant monolith of an application, and it was a big C++ thing running in IIS, some kind of Windows monster. And what it used to do was for running tests. So what I'm saying is this goes way back, right? The idea of running tests has been core to Expedia for a long time. You know. We're just carrying on the flame. And what it used to do was a bit mad. It used to push to our own internal data warehouse those exposures, so what customers saw, which button. And then separately, it would send all of those success criteria to our external web analytical system. So this would be like, this customer just booked a flight. That's the information that's then going out to our external system. And then what we basically do is copy that into our data warehouse. That was on a cycle of like once every, I don't know, 24 hours or something like that, maybe even longer. So there's like a big delay to it before we get those success criteria. And the testament dashboard, as I said before, relies on joining those two events together. And so the testament dashboard used to have to wait and run in a batch, and it used to be 48 hours before you get the results of your test. So let's say you put some kind of test out there that just completely tanks the whole site. You're waiting 48 hours before you have any sniff that that is going on. So yeah, that was the old days. It was still great in those days. Oh my god, it was all running on Hadoop, very modern technologies, very smart, very cool. But yeah, as we get closer to today, we kind of moved on. We moved into more of a service-oriented architecture. Still a really big monolithic web app. But one of the decisions that was made after that was to switch to, let's try and get closer to now. Let's try and be more real-time with our analytics of tests so that we can find out as soon as possible and we can turn those tests off. So that's when we created our real-time pipeline. I say real-time, it's kind of near real-time. Right? Close enough to know very quickly whether things are going wrong. So what happens then is the web application, as before, is feeding data in a stream via Kafka. So that actually says exposures and successes, so both of those things are now going all internal. So our solution is completely cloud-based, AWS. And what would happen is 70,000 of those a second it works out as, of those exposures. So we're talking quite a lot of information passing through this pipeline. We then have a storm topology, which is reading all of those messages. And what it's doing is it's building up a picture of every individual customer, and we're using Dynamo to achieve that in AWS. So every individual customer has an entry to say which exposures they had and whether they went on and booked something. That's in the region of 20 terabytes and climbing continually as we go through time. So fairly big in terms of data. Actually, it's pretty cool with Dynamo that it's mostly based on I/O operations, so the cost of it is like expensive for the now, but cheap for the old. So there's no real incentive to start getting rid of any of this data, which is kind of weird but cool. And then we have a Spark application, which is running off of the Dynamo data. So what the Spark application is doing is it's taking that granular data of every individual customer and it's aggregating it. So we're only interested in how did we do per 24-hour period. So how many exposures for this day? That's the level of granularity. Once you've crunched those numbers down using Spark, we get to something much more manageable, and we actually use Postgres to do this. And we've got a size limit of 500 gigabytes, which we haven't reached. So, you know, we're talking about a much smaller set of data, and that's what you see when an analyst comes along and looks at the results in the test and the dashboard. And that's what we're still running with. Some other bits, some more of the kind of like, that's like technology allows us to do a better job. and we evolve. But we've also had some pain points along the way. One of those was, at one point in time, we decided we would need to try and remember which treatment a particular customer saw. So you saw the algorithm I had. It has a flaw, which I'll try and explain. So the idea is, let's say you've been running your test, and actually you started off with a red button, a black button, and a blue button. So you had two test treatments, right? The red is what the site always was, and then you're trying out a couple of different colours. And you're running it at thirds, so a third of customers will go into each of those treatments. Well, if you then work out after running it for a week that actually, one of the buttons is rubbish, so you want to eliminate it from the test, but you want to keep running the test. You don't want to have to restart it all over again. You want to use that data you already had for the red button and the blue button. If you were to change the black button to be 0%, what would happen is this customer who originally got 0.45, so they were put into this bucket, right? They'll still continue to get this random number of 0.45 because their ID hasn't changed, the test ID hasn't changed. But all of a sudden, the line, the bar for the distribution has changed. So all of a sudden, this customer who was previously seeing the black button now starts seeing the red button. And as I said before, you can't let that happen, right? How do we know which one was the winner in that situation? And so we got this notion of if we wanted to allow this to happen and be able to run tests more quickly and get the results of tests more quickly and eliminate things like that and be able to change the distribution dynamically, the solution would be to add state to our beautiful stateless algorithm. And so the first solution was terrible. So we decided that we would run with a really big cookie. I don't know if you know, there's a limit to the size of a cookie on a site. After a certain size, it will just be rejected. And when you're running with hundreds of tests, and the customer's being exposed to hundreds of tests, you very quickly build up a list of which treatment did they see, and you reach that limit and game over. The solution doesn't work. So we abandoned that one. So then we decided actually what we would do is start storing it all. And it would be the job of the SDK to go off and look. So ask every time, which experience did this customer get? Which experience did this customer get? And to do that, we settled with Cassandra. But what ended up happening is it was beautiful when we were just running in our own data center, and page performance was kind of not a massive concern. That was absolutely fine. The millisecond or whatever that it took to make that request to Cassandra was fine. The replication within the data center was great. It suddenly got massively complicated when we started shifting towards the cloud. And all of a sudden, we had to transport that data around. So we started having to replicate the cluster across all of these different regions in AWS. Plus, much bigger focus within the company to improve page performance. Effectively anything which is adding even just a few milliseconds to every single request is very bad. And that's all based on search engine optimization. Right, so Google will drop your ranking the slower you go. So even small performance increases are a good thing right now. So what did we do? We killed it, which is pretty cool. So we went back from being a little bit unhappy to being happier again by completely killing the preserve feature. The good news is we do have an idea of how we can do it in a stateless way. So yeah, maybe one day we'll reinstate that. Yeah, but another cool thing we moved on to go even happier, climb the chart of happiness, is we started running experiments against things that aren't customers, which is, so everything to that point had been, okay, we'll run this and we'll distribute the experiment based on customers. There are certain experiments you might want to run that aren't customer focused. And if you think about it, if all we're doing is we're taking the customer ID and the test ID, why not take the hotel ID, the region ID, etc. And so that's what we've made available. And yeah, we've had some successes with running tests against, for example, region IDs. A good example, I think anyway, probably the wrong person to ask for a good example, but one I can think of is if you wanted to influence the search engine, so you wanted to influence spiders. A spider is going to come back to the site and it's going to appear to be a new customer every time. So if you're running an experiment against customers, the spider is going to see the test treatment in one request, then the control experience, and the test experience. You see what I mean? They're going to keep getting flipped between the treatments. So you're not going to know whether your test influenced your search engine ranking, for example. So let's say if instead you run it against something that's static to that page, like London. And therefore London is always in the test treatment, but Scunthorpe is always in the control treatment, for example. Then you know you've got something to compare then. So you can run a test and you can see that, oh okay, the Scunthorpe's ranking's gone way up, so our test was a success. So that's a pretty cool thing we've done. Pretty much the last thing I'm going to talk about really is where we're at now, which is where I said at the start we've got like the full stack running experiments, and we're very much moving towards a microservices architecture with as much in the cloud as possible. And so we actually are able to deliver experimentation to all of these layers. So whether it's a web application, whether it's the native mobile, whether it's a downstream service, so a geography service might decide, oh okay, we want to see whether increasing the size of the bounding box for Heathrow increases something. Then they can run those sorts of tests, which is pretty cool. So we're able to do it everywhere. And we do it everywhere, which is fair to say. So yeah, I'm going to kind of summarize with like, what are the keys to our success? I think the real main thing is what's been a driver in Expedia since, as far as I'm aware, day one. Obviously I wasn't here day one, so I can't say that for certain. There's other people here who probably correct me, but the test and learn philosophy in Expedia is from the top down, and there aren't that many things in Expedia, so as a company to work for, we're not really told what to do in a lot of situations. However, in this case, we are. So we test and learn on everything, whether it's process, it's nothing to do with engineering. We test and learn on everything. And the philosophy is fail fast. And that's really cool. And I think that feeds into the fact that Expedia treats it seriously enough to resource a team dedicated to experimentation. So yeah, we are resourced and we have a global team. So like I said, the team I manage has engineers in the US, India, in Europe. So we're able to provide support 24 hours. Self-serve is a really key thing. I really have not got a clue what experiments are running anywhere. The only time we get involved generally is if there's a support request. Otherwise, it's entirely self-serve. And that even includes diagnostic abilities. So if something has gone wrong with your test, your distribution is wrong, or I don't know, it's missing from the analytical systems for some reason, we provide tools that allow the engineers to self-diagnose. So we try and stay away as much as possible, really. Everything we do is scalable. So as we've acquired new companies, the amount of traffic that's going through our systems has massively increased, even just in the past year. And our systems are able to cope with that. We scale horizontally, we just throw a bit more money at it. And then I really think this is quite key, that our system is stateless, and I think that's one of its key differentiators. If you take that and compare it to some of the other solutions that are available to you. Ours is incredibly fast and incredibly performant. And you can't say that about some of the other solutions where you have to download large JavaScript libraries. They have to make AJAX requests. We don't have any of that. It's just in a nanosecond we get back the result and away you go. Yeah, and then the entire technology stack is running experiments, which is pretty key. So we're not restricting it to just UI tests. We're running them everywhere. That's me, I think. I'm done.